To solve a triangle means to find the measures of all the angles and all the sides of the triangle. Hello, my name is Tom Atwater, and in this section we will solve application problems using triangles. In solving a triangle, a labeled sketch is an important aid, like the triangle seen here. We have that side A represents the side opposite angle A. We have that side B represents the side opposite angle B, and side C represents the side opposite angle C. And when it's a right triangle as pictured here, C always represents the hypotenuse. All right, well, let's do an example where we find the sides and angles of a triangle. So what we have is a triangle in which we are given that angle B is 42.0892 degrees, and side B, which of course is the side opposite angle B, is equal to 56 and 851 thousandths centimeters. Okay, let me draw that triangle on the board so that we can work with it. So it's a right triangle, and we know that this angle is 42.0892 degrees. And we know that the side is 56.851. And this was B. Of course, we know that's C. This is angle A, so that's side A, and this would be angle C, which we already know is, of course, 90 degrees. So we can use the right triangle trig to find, for example, side A, because we know that opposite the angle 42 is the 56.851, and the side adjacent is A, so therefore the tangent of 42.0892 degrees is equal to the side opposite divided by the side adjacent. And therefore the side adjacent, which is A, is equal to 56.581 divided by the tangent of 42.0892 degrees. Well, let's hop onto the calculator and calculate what that works out to be. So what we want to do is actually take 56.851 and divide that by the tangent of 42.0892 degrees, which I have it in degree mode, and then I press enter. And what we'll find is that that side A is approximately 62 and 94 100ths centimeters, which is what originally we had. Okay, well, now let's go and find side C, which is the hypotenuse. And to do that, we can use either sine or cosine. So I'm going to start off with the sine. We have the sine of 42.0892 degrees is equal to the side opposite, which is 56 and 851 thousandths, over the hypotenuse, which is C. Therefore, C is equal to 56.581 divided by the sine of 42.0892 degrees. Once again, let's hop onto the calculator and plug that in to find our answer. So what I take is the side of 56.851, and I divide that by the sine of 42.0892, and I get that it's approximately 84 and 816 centimeters. And I, of course, rounded that off to the 3 decimal points as we did, or as we were given the original problem. Now, the only other missing part that we have here would be angle A. But we know that angle A and angle B, the given angle, are complementary. That is, they add up to 90 degrees. So all I need to do is just go directly to my calculator, and what I can do is type in 90 minus the 42.0892. Hit my enter key, and it works out to 47.9108 degrees. So I found all of the missing parts for the triangle that I was given in the original problem. Now, many applications of right triangles involve angles or of elevation or angles of depression. And here's the angle of elevation. It is the angle created between the horizontal, which is this line here, and what's called the line of sight. And by the line of sight, we mean here's the person observing, and they're looking from here, and they're looking up at some object that's above them. And that's why it's called angle of elevation, because the object they're looking at is above. Well, now let's take a look at the angle of depression. The angle of depression is, again, the angle between the horizontal, and this time the line of sight is below the person. Here's the person, and here's the object. And what you'll notice is that the object is below them. So the angle of depression is downwards. And the angle of elevation, of course, is upwards. Now, there is a caution that I'd like to show you. I want to caution you because you need to be careful when interpreting the angle of depression, because both the angle of elevation and angle of depression are measured between the line of sight and a horizontal line. Angle of depression would be looking down, angle of elevation is looking up. Now, here's an exercise where the angle of elevation is used to find an unknown quantity. Suppose the elevation of the sun is 23.4 degrees. Find the length of the shadow cast by Diane Carr, who is 5.75 feet tall. A sketch of this will be very helpful. So let's take a look at a drawing from the book that shows Diane Carr along with the sun. Diane, of course, is the 5.75 feet tall. The angle of elevation up to the sun from the ground, that is to say, you can see that we've cast her shadow right along here, and the angle of elevation is 23.4 degrees. And what we're interested in finding is this length, x, the length of her shadow. So, to find the length of her shadow, let me redraw that picture.